I don't know if I'm going to make it tonight. I've been up since 3 a.m. with kids.
I didn't get home till
Getting ready to get awake. I can't even keep my eyes open now. All right, differential equations. To find a particular solution of a given differential equation, so we talked about this yesterday, we're going to separate the variables. So we're going to do that same step of separating the variables. Again, we're using multiplication or division to do that. Okay. And then we're going to find the antiderivative. We're going to integrate both sides, just like we did yesterday. But the new part today is they're going to give us an initial condition. So we are next going to find the value of c. And we did not do that yesterday. So this is kind of that new step. We're going to get c. And then we'll do what we did and solve that differential equation for the variable that appears in the numerator. Okay? So it's not always y, I guess, is the hint. It's whatever variable's in the numerator. So very similar to yesterday, we're just going to get the c value today. So find the particular solution, that's how it'll be asked, to this differential equation with this initial condition, and here's our differential equation. So again, that fancy differential equation is just an equation with a derivative, no big deal. And we're just going to do those steps. We're going to separate the variables. We said cross multiply. Put that over 1, cross multiply. And then I'm just going to divide that x or y cubed over. So we've got dy over y cubed equals x minus 2 dx. Okay, and we said that's the part we've got to nail to start to earn any credit for this question. Okay, you have to make sure you separate those variables correctly. All right, and now you just kind of start racking up points here. It's usually worth 6 points. And then like questions part B and C will be worth the other 3 points to get to 9. But we're going to integrate both sides. Okay. So again, you have to use all your integration techniques. X minus 2, I'm going to start on this side because this is pretty basic. Literally just x and a negative 2. So that's just x squared over 2 minus 2x. And don't forget the plus c. And we're just going to keep it with the x as we said. Okay. On this side, I can't integrate when something's in the denominator there. If there's one term, I can just rewrite it. So I'm going to rewrite this as y to the negative 3 dy. Okay. So I just rewrote it, haven't integrated. Now integrate, add 1, divide by 1. Or divide by that number. So we get y to the negative 2 divided by negative 2. Equals all that junk still. Okay. And then I just personally don't like all these negative exponents. I'm going to rewrite this before I find that c value. So I'm going to call it 1 over negative 2y squared equals x squared over 2 minus 2x plus c. So again, negative exponents I usually just rewrite, and then I'll go get that value of c. So we did all of this yesterday. And now we're going to find c. So here's that condition. We're going to, when we plug in 1 in, we want to get out a negative 2. So when x is 1, y is negative 2. So I'm just going to carefully plug that in. I'm obviously writing out all the steps, but if you can do it in your head, by all means, go for it. Plus c. And then negative 2 squared is 4 times a negative 2 makes a negative 8. So I think I've got a negative 1/8 there. And then we just need to solve for c. So you can solve for c any way you want. You can clean things up, get common denominators. I'm going to get a common denominator here. So I've got 1/2, and I'm going to call that 4/2. Same thing as 2. So 1/2 minus 4/2 will get me a negative 3/2 plus c. And then I'm just going to add that 3/2 over. And then again, I just need to get a common denominator. So I'm going to multiply this by 4. So I've got negative 1/8 plus 12/8. So I've got c equals 11/8. Okay, and nobody says this c is going to be pretty all the time. Like sometimes you're going to get fractions or radicals or sine functions. Just go with it. Just trust the process. Okay, so now once we have that c value, we're going to plug it back into the equation before we plug the numbers in. So that was like back here. I'm going to plug that in. So we have 1 over negative 2y squared equals x squared over 2 minus 2x plus 11/8. And then your goal is just to get y by itself. However you can, you just need to get that y alone. And again, I'm going to go one way. If you went a different way, that's probably perfectly fine, as long as you don't make any, crazy algebra errors. I'm just going to multiply both sides by, since this y squared is down here, I'm going to multiply both sides by negative 2y squared. So that'll eliminate that. So I have 1 equals. Now, I'm only going to multiply the negative 2 through, because I want to get the y by itself. So I'm just going to multiply this negative 2 through to each of these. So that's going to get me a negative x squared. Those 2's would cancel. Plus a 4x minus a 22 over 8 times the y squared. And again, the reason I didn't multiply y squared through is because then I'd just be factoring it out to get y by itself, so I might as well just leave it there. And then I'm just going to divide this ugly fraction over to the other side. It doesn't have to look pretty, dividing it to both sides. So I've got y squared equals 1 over this negative x squared plus 4x minus 22 over 8. And yes, you can reduce that. And then to get that y alone, again, I'm going to take the square root. Now don't forget you get a plus and a minus of that square root. And they're all not this ugly. Figure if you can do the ugliest ones, you can do the easy ones. And then lastly, you have to determine now whether you want the positive or negative answer. And that's pretty simple to see because when you plug in a 1, you have to get out a negative 2. So if I plug a 1 in here, you can trust me, it's going to get me a 4 under here, which is going to be the square root of 4, which is going to be a 2. And if I want it to be a negative 2, then I only want to have the negative square root of this answer. Okay, so you're always going to put a plus and minus when you take a square root, and then you're going to determine whether you want the positive or negative based off whatever this initial condition is. Okay, so when I plug in a 1, I needed it to become a negative 2, so I know this has to be a negative. So I tried to pick 4 different types of examples, and like I said, they're all not this ugly. Some are nicer than others. But the idea is the exact same thing we did yesterday. We're just going to be finding this value of c. So give 2 a whirl. Find the particular solution. So that's how it's always going to be asked that way, to this differential equation, and we have this condition. So take a moment and separate your variables. Just slow down to the cross multiply. X is on one side, y is on the other. Separation was really nice. Integrate both sides. Side is my side. 3y cubed over 3. Okay, so now again, you got to trust your instincts with all this integrating. Anytime there's an inside, you need a u sub. There is definitely an inner function here. It's not just sine of x. So I have to use u sub. So my u is going to be my pi x. Derivative of pi x is just pi dx. And then I'm solving for that dx. Okay, so remember, that's our only tool for integrating is u sub. If it's not x to a power, we're probably using u sub. So I have the integral of the sine of u, and in place of that dx, I'm going du over pi. So I can pull out, so I've already integrated this side, so no more integral here. I can pull out the 1 over pi, that's in the denominator, and then I'm just integrating the sine of u du. Okay. So again, in trig, you just got to remind yourself, whose derivative am I staring at? Is that cosine or negative cosine? Negative cosine. Good. So I've got my y cubed equals negative 1 over pi cosine, and I'm going to plug my u back in, my pi x plus c. I'm just integrating sine, which is negative cosine, put my u back in, and now I got to solve for c. So we're going to use that initial condition, plug in my 3 and my 2 to solve for c. All right, so now I got to think about my cosine of 3 pi, which is a fairly nice one because I'm just using the cosine curve. So pi over 2, pi, 3 pi over 2, 2 pi. Cosine starts at its max, 0, min, 0, max. Okay, so that's how I'm talking it out to myself. And you can draw the curve if you want, or just think about the points. At 1 pi, cosine's at negative 1. At 2 pi, it's at positive 1. Which tells me at 3 pi it's going to be back to negative 1. So that just turns into a positive 1 over pi plus c. If we just said that turns into a negative 1. So c, again, just an ugly c value, but just trust the process, is 8 minus 1 over pi. And then once we have that, we're going to go back to that original equation where we had c and substitute that in. So y cubed equals negative 1 over pi cosine of pi x plus 8 minus 1 over pi. And then lastly, if I have y cubed and I want y by itself, I'm just going to take the cubed root of both sides. Now, cubed roots don't get a plus minus, so it's just the cubed root of all that jazz. Got it right there. So like I said, we typically see these in the free response the most. Because obviously they require a lot of work, more than a typical multiple choice question. But I love these. This was one of my favorite classes in college. Took 3 years of it, just for fun. Let's try another one here. Number 3. Given h equals 16 at t equals 0, where the height is h in inches, and the water in a container at time t, I don't know what this is, kill that, minutes, that's supposed to be. Solve this differential equation for h as a function of time. Okay, so just to be clear, the variable on top is h, so that is the variable we are going to be solving for, whatever's on top. So go ahead and do your cross multiply, separate your variables. Hopefully that matches yours. Just cross multiplied and then divided that root h over. Okay. We'll slap an integral on both sides. Okay. Now again, this is just one variable, so I don't need a u sub, I just need to rewrite it. It's really just h to the what power? 1/2, and then to bring it upstairs would make it a negative 1/2. So I'm going to rewrite that as h to the negative 1/2. Okay. So I'm still integrating that, dh, and then I'm integrating dt. Okay. So that's going to become h to the add 1, or 2 over 2, h to the 1/2, divided by 1/2 is the same as multiplying by 2. Although there's no variable here, what number can you always assume is in front of that? A 1. So what would if I integrate 1, I get what variable? In this case, it's going to be t because it's a dt. So normally an x, but in this case, we're going to say it's t, and then don't forget the plus c. Okay, so I've got negative 4 h to the 1/2 equals t plus c. And then we'll just carefully plug in when t equals 0, h is 16 is the condition. So that h to the 1/2 I just rewrote as the square root for myself. Square root of 16 is 4. I think I've got negative 16 as that c value. And then I'm going to take that and plug that into this equation here. 16. Okay, I'm going to divide everybody. When you divide, just make sure you divide all your terms by 4. You can either write it as the whole fraction or divide each one separately. Doesn't matter. H to the 1/2 equals t minus 16 over negative 4. And again, a 1/2 is like a square root. So if I want to get rid of that, all I have to do is square both sides. Good. So we get h equals that t minus 16 over negative 4 squared. Okay, and this is that specific equation that when I plug a 0 in, I should get out a 16. That solves that one. What's this last one look like? All right, I think I'm going to give you some time to practice. I'm going to skip this one for now. Oh, maybe I'll do it just to practice the integrating. Let's just practice the integrating one time. Go ahead and cross multiply and separate your variables. Just want to, obviously, we've got to be able to integrate these. The left side, whose derivative are we staring at? The derivative of sine, so we just get sine of v. Okay, this side, again, I have an inner function. The only option is a u sub. Make sure you're using u sub. U to the 6 and du over 3. And u to the 6. U to the 7th over 7 plus c. We do the u sub, substitute it in, integrate, we should get u to the 7th over 7. Multiplied that 3 and 7 to get 1 over 21 and plugged my u back in. And we just want to work on finding that c value with the initial condition 1 and 3 pi over 2. So again, the sine of 3 pi over 2 is just coming from that sine curve. 0, pi over 2, pi, 3 pi over 2. So I think we talked about that grizzly for Friday, and somebody asked, what they're supposed to study. I guess if I had to pick one thing to study, it's your trig values. I mean, we haven't practiced those in a while, but they do pop up in a lot of questions on, every test we're going to take from this point out. So you base, your 30, 60, 45s, and then your graphs. I would make sure you know your trig values. And if that's something you want to jot down at the top of your test every time, if that's helpful, by all means do it, but you want to make sure you do know those. So the sine of 3 pi over 2 is -1, and then we get 3 times 1 is 3, minus 4 is -1, -1 to the 7th is still a negative, so -1 over 21 plus c. If I add that over, plus 1 over 21. I'm going to call that 21 over 21. I think I get -20 over 21 for my c value. And then plug that back in to get that original. Yes, I will let her know. Okay. So let's see, we're going to put that back in that equation. So I've got the sine of v equals 1 over 21, 3t minus 4 to the 7th minus 20 over 21. Just plugging it back in. Okay, and then we talked about this yesterday. The only way to get rid of a trig function is to take its inverse. That's the only way to undo it. So you can either use the inverse symbol or the word arc. Okay, so you can sine inverse each side with the -1 notation, or you can use the word arc sine. Either one. So I'm going to say v equals sine inverse or arc sine of this side. Okay, but that's the only way to get rid of a trig function is to take its inverse. All right, so we're going to grab some scrap paper. We're just going to have at it here. I'm going to get some answers to compare to. I know I have a ton of problems. Obviously, just for practice, it's a pretty heavy topic. We're not going to do, obviously, all of these for homework, but let me get some up on the board and grab some scrap paper.